Welcome to a Math Warehouse video on SAT prep involving the equation of a circle. Here's the question. The graph of x squared plus y squared plus y equals 225 over 2 in the xy plane is a circle. What is the length of the circle's radius? So before we try to answer this, I just want to remind you that we've been exploring circles with the standard form equation, which is what you can see up on the top here, where it's x minus something squared plus y minus something squared equals 5 equals the radius squared, 5 squared. In this case, it's x minus 4 squared plus y minus 3 squared equals 5 squared, right? That means the center is 4, 3, and the radius is 5. We've done this in a bunch of the prior videos. If you haven't seen them, check out this playlist, which goes over all the different ways the SAT is now asking these questions. Okay, unfortunately, you may have noticed a little thing about this question. The form of the left side does not look like our nice x minus something squared. It's a bunch of junk over here. So what we're going to have to do is to take this equation and convert it into something like that. And to do that, you have to do something called completing the square, which is a pretty complex lesson that teachers often spend at least a whole day doing, and I'm going to run through it pretty quickly, but you may want to spend some time researching completing the square if my quick 2 examples is not enough. Basically, there's a formula for completing the square, and let's look at this expression, x squared plus 20x, and the formula centers around the number before the x, the coefficient before the x, which is 20. So you take 20, you divide it by 2 to get 10. Then you take 10, you square it to get 100. And now we add that to this expression to get x squared plus 20x plus 100, because now we can write it as x plus 10 squared. Now I want to point out we changed this expression. X plus 10 squared, which is x squared plus 20x plus 100, is different from that. So when you have an equation, it's going to affect the full equation, and that will become a little more clear in a second when we look at an example. Here's another example, just an expression, but then we're going to look at it in an equation. So let's complete the square for x squared plus 16x. Again, the key is the coefficient before the x, which is 16. Divide that by 2 to get 8. Square that, 8 to get 64. And now add that to the end of the expression, x squared plus 16x plus 64, which we can rewrite as x plus 8 squared. Again, our goal is to take the x stuff over here and make it something like that. And the key is to use this formula. But we have to talk about something. This is an equation, and what we've looked at so far have been expressions, right? So let's slightly change x squared plus 16x by changing it into an equation. And let's complete the square. We're going to do the exact same stuff we did up top. We're going to divide 16 by 2 to get 8, square 8, add 64. But now what this example is showing you is that when you add 64 on the left side of an equation, you also have to add 64 on the right side. So now we have x plus 8 squared equals 100. But this is the key to what we're going to do with our circle. We're going to complete the square for the x to change it into something like this. Whatever we add, like a 64 or whatever, to the left side, we'll have to add to the right side. And we'll repeat the process for the y. And whatever's on the right side is of the original equation of the circle up here, whatever we end up with over here will help us find the radius, because you know that the right side equals the radius squared. Okay, so let's complete the square for both of these, x squared plus x plus y squared plus y. Now the good news is it's pretty much the same thing. We have to complete the square for the x's and for the y. So the number in front of the x and the y is 1. I just rewrote it in my crappy handwriting here. X squared plus 1x plus y squared plus 1y equals 225 over 2. So if you remember, what we do is we take this number, this coefficient, divide it by 2. That's 1/2. Now do you remember what we do next? We square it. That's going to give us 1/4. So we're going to add 1/4 for the x, so that we can have a nice expression for the x, and we're going to add 1/4 for the y. Then add 1/4 on the left side of the equation. Do the same thing on the right side of the equation. So the right side is a pretty ugly fraction, 225 divided by 2 plus 1/4 plus 1/4, and the left side becomes x plus 1/2 squared plus y plus 1/2 squared. Now we just have to simplify the right side. 1/4 plus 1/4 is 1/2. So the right side is going to simplify to 226 over 2, or 113. Now check out our equation. It's ugly, I'll give you. We have these fractions here and there, but it is in the standard form. we don't even care about the h and the k, the 4 and the 3. We care about the right side because they are asking about the radius. So the right side is 100 is the radius squared, and it's 113. So the radius will end up being the square root of 113. Okay, that's the whole question. A little bit complicated on the algebra front. And the original SAT question looks just like this with a slightly different fraction, but it was the same kind of ugliness to do that SAT question.